Okay, so today what we are going to look at is we're going to look at the math problems that are in your slides. These are with kinetic energy. So we have kinetic energy, and then we're going to talk a little bit about potential energy. So kinetic energy, we have here, it says kinetic energy is energy due to motion. The kinetic energy from an object's motion depends on the object's mass and speed. So it's always measured in joules, which is kind of important, so make sure you understand that. So your kinetic energy will always be equal to joules, all right? And we do the math looking at it's half your mass times your velocity squared, all right? So anytime that we're doing this, we're going to square our velocity and then take half of its weight or half of its mass. So let's go ahead and look at a practice problem for this. Okay, it says a jogger with a mass of 60 grams is moving forward at a speed of 30 meters per second. What is the jogger's kinetic energy from this forward motion? All right, so the kinetic energy is what we're looking for. So that's our question mark. Our mass is 60 kilograms. And our velocity is 3.0 meters per second. All right, so remember that our kinetic energy equals 1/2 the mass times the velocity squared. All right, so if we set that up, kinetic energy will equal 1/2 times 60, all right, times 3.0 meters per second squared, all right? If we solve for this, what we're going to do first, order of operations, do our exponents, so that's going to be 9 meters squared and seconds squared because it's meters per second, all right? And we're going to times that by 60, and we still have 1/2. All right, so now all of that is there, and we just go ahead and go right through it, multiply 1/2 times 60, which is 30. 30 times 9 is what? That would equal 270, so our kinetic energy is going to equal 270 joules, all right? And that's how we work this equation, all right? We square this first, and then we multiply across. Pretty simple. Any questions? If you do, feel free to email me, and I will talk to you about that over email. All right, now let's go into types of potential energy. All right, so we have different types of potential energy, and one of them is gravitational potential energy, and that one's huge, okay? This one deals with gravity, and we have to remember that we are dealing with gravity, so it's always 9.8 newtons per kilogram. So gravitational potential energy is energy that is due to the gravitational forces between objects. Recall that Earth's surface gravity is equal to 9.8. Our equation is gravitational potential energy equals mass, which is kilograms, times gravity, which is newtons per kilogram, times your height, which is meters. So it's GPE, which is gravitational potential energy, equals mgh. All right? Go ahead and look at this equation now. So what we're going to do is just do the same type of work that we did in our last math. It's pretty simple. We'll fill in for our variables, substitute them into the equation, and then solve. All right, so it says a 4 kilogram ceiling fan is placed 2.5 meters above the floor. What is the gravitational potential energy of the Earth's ceiling fan system relative to the floor? So we're looking for gravitational potential energy. It says, what is that? So that's our question mark. Our gravity is always 9.8, so that won't change. Okay, our mass is 4 kilograms. And our height is 2.5. We substitute that in. So our GPE is what we're looking for, will equal 4 times 9.8 times 2.5. All right, we can work that out on a calculator pretty simply, and you just multiply across, so 4 times 9.8, so we're looking at 10, so we're looking close to 40. 40 times 2.5, easily we will get 98 joules. Okay, and because we're in energy, energy is always joules, and that's our final answer. All right, and again, like I said before, if you have any questions, please feel free to email me, and I will help you as much as I can. Just substitute, again, fill out your variables, substitute them into the formula, and then solve. All right, email me if you have any questions, fill out your notes, get your work done, and I'll see you on Monday.